Welcome all of you. Myself Abhishek from MIDAS IT from the technical team. Today we will see about the truss element, how to model the plant structure in the MIDAS Gen. So and even we will use the wizard to generate the truss elements. We can say the triangular truss element. So by using these options we will see. So first I will just open the another this one model and I will tell you this is the one type of the truss element we will model. So externally we will see the various columns at external, internal, and the truss, inclined truss, even the bracings we are using. Even we are using the we can say the loading, the lateral loading we will define the manually, because the previous lecture we will define about the automatic loading, but today we will see about the manual loading. If you wanted to apply the wind loading manually, so we will see in this particular project we will apply the lead load, light load, wind in x direction, wind in y direction. Even we will apply the roof wind load also, that is in the vertical the your elements, so in the inclined direction. This type of the loading we will assign, and these are the some materials and the sections we are using. So like you can say the material type we are using the A36, section type W16 by 67 for the exterior column up to the roof level girder, then W14 by 90 interior column, W18 by 65 for a floor girder or the beams, then W4 by 13, that is for the top bottom chord of the exterior truss, and WT 724 top bottom chord in the interior truss. Missing the internal also we will change, and then WT 4 by 9 vertical and the diagonal members of roof trusses, and L4 by 4 by 5 by 16, that is the wind bracings we will use. So now we will see how to define this material and these things. So I will just open the Midasian. Okay, so this is the Midasian. We will start for the Midasian and we will model the entire thing and the even the design also. So I will show about the design parameters also. First I will say file, new project, and I will save the first this file into the some defined folder, so that next time onward no need to save this file, the program will automatically save. I just say desktop and just say a webinar, and sorry, it's already there. Yeah, webinar, and okay, sorry, it's already there. So I just use the name, say truss or sorry, plant structure, plant structure. Okay, and just save. Now this is the one file I saved it into the one folder. So next time onward program will automatically save the file. If you wanted to change the duration between the save option, so we are having this option, tools, preference. Now here you can see auto save in every 5 minutes. Now in my system I have set for the every 5 minutes, but in the by default it is the 10 minutes. First we will define the material properties, sections properties, then we will start for the modeling. So first go to the properties, say material properties, add steel standard ASTM and say A36. okay, now you can see one material is done. If you want to define another, you can define it, and here you can see the modulus of elasticity, Poisson ratio, thermal coefficient. These values are mentioned here. If you want to modify this data, instead of standard you have to say none. Now this data is editable in format. Now you can edit. At the time of editing this thing, you have to check always the unit of the next to of this particular box. Next box is section. I will just say add, and I just say first I section, say AISC. I just say use the AISC, and instead of here I will just say W, say 16 by 7, sorry, 16 by 67. Okay, and I just say apply. Now this property generated. Similarly W14, 14 by 90, apply. If you drop down here also, you can find out the properties, say W18 by 65, say 1865, apply. Now these three properties are generated. Next one is for the top and bottom chord, say W 4 by 13. So W 4 by 13, apply. Now the last it's about the, now we will use the another this one, say T sections. I just changed from the sections here, say T sections AISC. Here I will say WT 7 by 24. 7 by 24, apply. This is the T sections. Another one is the 4 by 9. Apply. And the last property for the wind bracings, which is at the L shape, I just say L angle AISC, and I just say L 4 by 4 by 5 by 16. 4 by 4 by 5 by 16. So this property, and I just say okay if I wanted to close it. If you wanted to add some the plate or something, say you can just say add here. I just closed it. I mean the works. Now you can see the entire thing. Now it is coming into the blue color, means this particular property you have defined, but still you have not assigned anywhere. So from this particular tree menu, you can identify how the program is define the properties. Now here you can see only the properties you have defined in the structure, so it will show only the property. If you started for the modeling part, so the entire thing will automatically coming into the tree menu. So you have to always check the tree menu and the message window. Now I go to the structure, sorry, in the view, the various views are available. Now it is the top view. So here you can change the view by using the viewpoint. If you want, you can go for the top view also. I just click on the top. Now I go to the structure, and now I have to define the grid lines. I can just say grid define point grid. Okay, I just use the define point grid and the line grid. If you say point grid, it will only generate the point, and if you want the line grid, you can just say line grid. So I just use the define line grid, say add, and I just say here say floor, that is for the one floor. Now x direction, I just say add. Now here you can say I can define the distance. So I will say 2 at the rate 10, means 2 is the numbers and 10 is the distance. So first my x direction, I want only the 2 rows, so that is the 2 at the rate 10. Now second, I just say y direction, add, say 4 at the rate 8, means y direction 4 meter 4 times 8 meter distance. Say okay. First one is the number and the second one is the distance. You can see here 0, 8, 16, 24, 32. Okay. Now here I just use the zoom fit command. Now you can see all the grids, entire thing, it is set. Now you can model by using these options. Okay, what I will do first, I will generate the beam and then I will go for the column. For draw the beams, what I will do, say nodes and element, and I just say create element, and in the create element say general beam and tapered beam A36 name. Now here the name is most important, how the you are defining. So here I'm using the W18 by 65, which is I'm using for the floor girder or something. I just click here, say nodal connectivity, first point, last point, first point, last point, first, last. So everywhere I have to draw, and the later on I will draw the beams. I'll always try to draw from the left to right and bottom to top, so that the local axis will match properly. Otherwise it will create the problem at the time of applying the loadings. Now I will just select the exterior, this one, say 1, 2, 3. I just use the top view, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so in this particular, this one and this one, I'm using the different property. At the exterior, I just say instead of that, what we can do is I will just select all these nodes. Now in this all these nodes I will explain you how the things we can define. First I just say select this one, say this one, I this all the nodes. Now you can see all the nodes are generated. I just open this one, come to the nodes and element, and I just say extrude. Now in the extrude we are having this option node to line element, say beam A36. Now section, right now I'm using the same section throughout, say W16 by 67, and I will just rotate. Okay, I just say it's a -4 meter for the gravity direction bottom side and apply. Now you can see all the columns are according to the 16 by 67 and all the beams are here W18 by 65. Now I will go to the select single option and I select the internal columns. Now I wanted to change the property of internal column. I just select these three columns, come to the W14 by 90, okay, which is the internal column. Just click here and drag it to the screen. Now this property is changed. So everything is done now, my column and one floor. Now I wanted to draw the secondary beam. In this area we have not modeled anything, and in this area we will apply the loading and entire thing. So what I will do is I will just delete first these beams and I just select this particular beam, okay, this three beam, and I will copy into this other direction. And for the copy we will use nodes and element, and I wanted to copy the element, so you have to use always the element translate box. Okay, if you use the nodes translate, so it will only translate the nodes, but if you want to copy the elements you have to use the element translate. Say copy, x direction is say 2.5, say 3 times, and just click on this option, copy the element and attributes, copy the node and attributes, and the nodes and the intersect of node and element. So first is intersect and node and element means what happen, wherever the nodes and the element will intersect, it will automatically break the element. And the second thing is copy node attribute means if you click in this dot box, you can identify the support condition or any other options, so the program will automatically transfer. Same way for the element also, if you wanted to release beam and entire thing, if you wanted to copy into the same, you can copy. I will just say apply. Now you can see all this structure is generated. Okay, so by using this particular three options we will generate the entire thing. Now we'll go for the next part about the we can say copy it into the another two levels. So I just select all and just go to the structure, control data, and I just say building generation. Okay, now in the building generation I will just say it's a 4 meter, add, and I just say apply. Now one more floor is generated, and now I will just select the front view and select the only the columns. Okay, now you can see only the column I will select, and again I will say structure, control data, building generation, and I will again say 4 meter, but this time only the column I wanted to replicate. I just say apply. Now you can see all the columns are replicated. This is for the column, means which are the elements you wanted to copy, you can copy easily by using this method. Now I will go to the next part about the wizard usings. So I just come to the structure, base structure, or before wizard what we will do is we will first define the your inclined members, which is we can say the wind bracing. Say we will use for the L4 by 4 by 5 by 16, this particular L section we will use for the bracing. So this bracing we will define. So again I go to the nodes and element, say create element, general and tapered beam, say 36 W16 by 16 7. So instead of that I will say L4 by 4 by 5 by 16, say nodal connectivity. I click first point, second, click here, and this one and the middle, this one and the middle. The program will automatically take care of middle node, no need to calculate it or no need to define in this way. and if you want you can copy also. This command is available for the rotating the command, rotating the your file. I just rotate. Okay, now this one is generated. Same way above level, I just copy. Otherwise at the time of copy the element you can copy. So this type of the error you cannot face. I just select this point, this point, this point and this point, and here also I will just select this one and this one. Now only these areas I will define the entire geometries. So bracings only for the this L shape, this L shape, this one and this L shape. Okay, now we'll move for the next part, which is for the wizard part. Now for this wizard, what I will do is I will just first select the say structure, base structure, say truss. Now in the truss, here we are having these types, so I will just select this one, then this one is okay. Say panel 4, it is okay. Number, distance, I just said 10 meter because from this column to this column my distance is 10 meter, so I just said 10 meter. Height is 2.4, instead of that I just said 3 meter. Then symmetrical, now you can see for this opposite direction also I want, I can see, and if I say show dimension, you can see this is the 10 meter, height is 3 meter. Now I come to the next box, edit. Say I click here vertical. Now I want the verticals also, the members. I just select the vertical. Material A36 throughout. Section, here I will use say a W 4/13. Okay, now in the top, if I click here in the top, which material you want, say 1 is the number, you can see here A36, the number is 1. Now for the section I want the 4 number, so I just say top is 4 and bottom is 4, and at the inclined means in the diagonal, or you can say the vertically, the vertical and the diagonal member of the roof truss, I want the WT 4/9, that is the 6 number, I just say 6, and here also I will just say 6. Now this one is done. The numbering, this is only the number you have to mention, because if we define about the name of the particular section, so the dialog box will increase this, it will increase the size of the dialog box. So because of minimizing these things, we are working only in the numbering, and this numbering you have to, according to the tree menu, you have to input. Now I will go to the insert. Now where I wanted to insert, so I just say insert point, I just click this top point. Now you can see 0, 0, 8, because this is my 0, 0, 4 meter, then 8 meter. Now in the 8 meter I will apply origin. If I click here, it will show this is the origin one. So I wanted to, according to this origin, I wanted to apply. I just say apply. Now you can see all the my truss is generated. I just click the front view, you can see this one is generated. If something you wanted to modify, you can modify it here, otherwise you can go ahead. So these are the things are available to modify the element. I just generated this one, I just select this particular top chord, sorry, yeah. Now you can see all this top chord is selected. Then I will just go to the nodes and element, say translate. Now copy y direction, I just say 4 times 4 meter 8 times, and say nodes and elements here, even I wanted to copy this one, apply. Now we can say entire thing gets generated. So what I will do is I will first select this bottom row and say activate, and in the top you can see this one. Okay, now in this dot I will generate the my beams. So I just say create element tapered beam A36, say W, the instead of W here we will use this one option, floor girder, say W18 by 65, third number property. I click here, nodal connectivity, say first point, last, and always check into the this one it is coming proper or not. I just click. Okay, now for the wind bracing, one more option you have to do. You have to click on here, and I just say L4 by 4 by 56. Click here and just use this box. Say first close cross boxes. Only the periphery row. I just select this one point, second point, and only for this closing box I will just select the beams. I just select this one. So one by one box we can generate. If you want, if the distance are proper, you can copy paste also from the one boxes to other box. Okay, now you can see entire things are generated. I just closed it and I just say activate all. This one activate all. Now entire structure you can see. Now only the thing is remaining, that is only the top chord. I just say create element general beam A36, say W16 by, instead of W16 by 67 I just say W18 by 65 for the top chord. I just select here, say top point, this one, and this top point. You can see entire things are generated. Okay, same way for the other direction also we can copy. So what I will do is I just select this particular truss, top truss, yeah, just rotate it, yeah. So I just select this one, again create element A36 W 18 by 65. Instead of that I can use vertical, okay, 18 by 65. Click here, this one, this one. Okay, now these two in the interval we will use it. Okay, now next boundary, after that we have to define the boundary condition. Now for the defining the boundary condition we have to select the first nodes, and according to the nodes we will fix it the bottom, this one. So I just go to the first view and select, we will select the plane and just say XY plane and click here. Now you can see all the bottom nodes are selected, and I just say boundary define support replace. Generally I used replace command, so the previous what are the support conditions are that it automatically replaced. Say D all, that is the translation all, and R all, that is for the rotation all, and apply. close. Now in the tree menu you can see, I just say display. You can see here this type of the support conditions are defined. Now I will open the one floor. I just select this one, only this area also it's okay. Now here I wanted to define the first loading, that is the we can say dead load and live load floor loading by according to the one way loading. In in the shorter span direction means in the longer span I wanted to apply the loading. So what I will do is I can go to this option loads, static loads. I just say static load case. First is dead, say DL. My type is dead load, add, then LL. My type of load is live load, add, then my I just say wind X, wind load on structure, add, wind Y, add, and then lastly roof wind load, add. I just say close. First self-fed, I just click here, dead load -1, add. So in the dead load program will calculate the self-fed of the structure. Node load to masses, this is for the seismic weight calculations. Then I go to this option assign floor load, and here I just say define floor load type, and I just say typical load case, say dead load. I just say -2, 2.5, so that is the self-fed or maybe something the floor finish or something it is coming into that particular panels. Instead of that I can just say 4 because 2.5 is the self-fed and the additional area, and just a live load I just say -3 and add. So in this way you can define the various grouping of the particular load. Then I will come to this option assign floor load, say typical. Instead of one way I just click this point, and before you have to do something you have to always open this box, say in the display load floor load area. Okay, in the floor load area you have to always click floor load area and the floor load, so that program will tell you about the sizing. I just click here, say first point, last, this one, and this one. Now you can see here according to this one it will applied into the vertically. I just say undo, and I will you have to say the 90° or the 0°, but I wanted to copy it into the above floors also, so I just say undo it, and I just say copy floor load. I wanted to copy it into the above 4-meter level, so 4 meters. So this one I already applied, and it will copy the load into the above level also. I just click here, first point, second, third, fourth, and the fifth. Now you can see this load is applied. I just say close. Now here you can see right click display. Now you can see the value that is in the dead load. If I right click and if I say display, now you can see the value it is in the live load. So this is the total load which is applied into the beam. It is not the kilonewton per meter square value, it is the total load. Now what I will do is I just select the first columns, external columns, say activate, and I wanted to apply the loading. So first I just off these particular bracings. Yeah, now in the particular this one I wanted to apply the loading, so I just say wind X, and what I will do is I just select this one column, this column periphery only, this column. Now in the wind X direction I just go to the line load, beam load and line load element, and instead of I just say wind X, replace uniform load, I just say global X, and I just apply the value which is 9.8 kilonewton per meter, and just say apply, close. Here if you see line load display, now you can see this value. For the external I just apply this one. Again I will select this one internally, and just say beam load element wind X, replace say a global X, and here I will say 4.9, apply. Now this one is done for the internal and the external. Now what I will do is I just select this particular columns, this one, and this one, and I will say say wind y, say global y, and the value should be say 6.1, close. Now here right click and display. Now you can see this value, it is in the y direction. So in this way you can apply your manual values. So what I will do is now I will just select the roof truss, the top, this is one. Say activate. Now you can see I just select this particular all members and I just open, just click here display, and if I wanted to see the my view, I just go to the elements and just say local axis, apply. Now you can see all the vertical jets are there. So I just apply the load into the z direction, say beam load, element, say roof wind load, replace uniform load, and here I will say local z, so that the load will applied the inclined in the inclined direction. So I can use the these two options is, and here I will apply the value, it is in the positive direction, so internal wind will also apply, and my value will be the just say 5.4 and apply. Now I will show this one display. Now you can see internally and according to the inclined member it will apply the loading. So this type of the loading also you can apply. Even you can apply the point load also. If something is there, you can use nodal load option. In the nodal load, fx, fy, fz, moment, these values. So depending upon the your values, you can define the entire loadings. Now our wind load and entire thing it's done, and based on that we will define the entire structures. So one thing is remaining is top guard of the truss of external truss. Okay, so about the this one values, actually for the internal and external we are using the different value. So I just wanted to change it, so I just use this one, say W14/13, apply. Now say 3D, okay, sorry, top view. Only for this external we will use the different value, and the internal we will use the different value. So for the internal, sorry, we will use this internally. Yeah, I just select this one and I just said W7/14, drag it to the screen, apply. Now external the values are different, internal values are different. And one more thing is, if I wanted to see the joints, each and every joint, so you can use this option, say view, and just use shrink. Now I will just zoom it and I will show you how the things. Now you can see here each and every joints you can see proper. You can see each and every element you can see properly. This is the T section, this one, this one. Now if you wanted to change the orientation or something of the particular element, you can just select it, just go to the nodes and element and just say change parameter, and here you have to say element local axis. Now here you can define your own angle and it will program will automatically change the local axis. So these options are available to change the local axis. Okay, now up to the loading and the entire thing is done. The next procedure is to the before run analysis. We have to do some settings, like if you see the members, entire members are set according to the joint to joint. If you wanted to top to be the flushed, go to the structure, say structure type, always click on the convert sulfide into the masses. This is generally used for the seismic analysis, but you need to click, then just click on the align top of the beam section with the floor and the align top of the slab with the floor. I just say okay. Now here if you zoom it, now you can see the entire thing, its top is a flushed. Even this particular top is flush. Second, check duplicate element. If something is there, program will automatically take care. Then in the boundary we are having this option panel zone effect. beam end releases. Beam end releases for the do not wanted to transfer the movement into the another beams. And panel zone effect, it is for the if you wanted to calculate the movement at the face of the member, so you can use the panel zone effect. Generally it is most important in RCC structure. Steel structure it is not required, but this option is available. Loading, it's already done. If you want, you can generate the seismic load and the wind load by using the lateral functional, and for that reason you have to generate the structure, control data, and the story. I just click on the story, say auto generate story data, the program will generate, and I will just say and okay. Now yes, the program will automatically generate these 3 floors, roof and this one, and the based on this particular floor program will automatically apply the lateral loading. So I just go to the loads and I can define the wind load and the seismic load, which is the program calculated. Go to the analysis and I just say perform analysis. Now you can see the 39 errors are there. I just come here and now here I can see 183, 223. So I just click here. This is the node number, say 210. Now here you can see singular error, warning 210. So I just click here and just say 210, click. Now here you can identify. Okay, so because in the vertical member it is joined, and this vertical member if you see it is considered as a truss, so we need to release it. So I just click here and now so I just select vertical members, because if you say truss and then it will release the moment and it will not create the moment, but here the moment is created because it's a vertical element. So we need to change from the truss, because truss only the inclined members are there. So I just select this one and I just say nodes and element, change parameter and element type. Instead of truss I want general beam and tapered beam, and say apply. Now I will just run it. Now you can see there is a no error. So in this way we can change our loading and entire thing by using these options. Now we'll move further. Result, first option is load combination. I just click here, say steel design, say auto generation, steel design code AISC 14th LRFT 10, and I just say okay. All the combination and entire thing it is generated by the program based on the code. Then I will go to the reactions, say reaction force and moment. I can select the any one combination, say XYZ value, and apply. Now you can see everywhere the values and entire thing it is mentioned. Even you can use arrow scale factor to change the arrow or something. Deform shape, if you want to see the deform shape, I just click deform shape, say wind X dx. I just off the value, just say animation, apply, and if I click in the center, now you can see the animation will start. Yeah, so in this way the animation will start. So this option is available. You can, the program will automatically start and you can save this particular animation. If I want to close, I just click here close and say view, initial view for the original shape. Then I go to the results, forces. We are having the truss forces, beam diagram and entire thing. I just click on the beam diagram, say dead load or any combination. If you want to see the particular column values, so I can just zoom it and I just say fx for the axial force value all and apply. Now you can see here value. So this is the minus 20.8 in the CLCB1. So in this way you can check the values at the particular this one. What are the values? Now 84, it's a 210. It is a cumulative value, so it is generating. Then if you say movement, say my, apply. Now for the beams, here internally you can see this beam bending moment diagrams. So these are the things are available. If you want to see the particular diagram, so you can use this option quick view, and I just select the CLCB one and just select the one member. Now here you can see the program will automatically generate the this one. Okay, now you can see here entire thing it is generated by member wise. If you click, then by member wise program will automatically generate, because here the program is divided into each and every panels. And the other data like in the result table, story, we are having this other data: story, shear, force, stability, overturning, irregularity check. Various checks are available. This option is available in the result and the result table in story. Now I come to the another box about the designing. So before going for the designing, we are having the two options. So I just come to the first design, and in the design, general design parameter, we will use first definition of the frame, and I just select the auto calculate effect to length factor, so that program will automatically calculate it. I just say OK. Now the second, if you want to change something, I just use the member assignment, say automatic all, and apply. So what is the member assignment? I just click here. Now we can see this particular member. Now this is single member which is divided into the number of parts. Means you can say one part, second part, third part, fourth part. Okay, now in this way it is divided into the number of part, but for the designing I want to consider from year to year as a single element, so we will use the member assignment. So program will automatically consider based on that. Here you can see from year to year it's a single. If I click here, you can see here the program is considered from year to year. So these options are available. Then if you want to define your own value, unbrushed length, effect to length factor, limit slenderness ratio, so these are the options are available. You can define your own value. Now I come to about the designing, say Euro code. Instead of that I just say AISC 14th LRFD 10. Then in the still design I just say design code. If you want all beams and girders are laterally braced, or special provision for seismic design, if you want you can consider here. Just say OK. So still design, say modify steel material. If you want to modify some data you can modify it. And in the still design we are having this option, seismic load resisting system by the member, so you can apply it according to that. Now if I say steel code check, I just first say steel code check, the program will check my member based on my load combination and entire thing, and the program will tell you how the whether the sections are pass or fail. Now here you can see these sections are fail, blue one, and this one it's nearby to the fail. I just maximize. You can see the ratios. My ratios are coming 0.923. Here it is the accurately coming 1, means might be it is the values are coming 1.001 something. That's why it is failing. Here also the values are going more than the required this one, so we need to change it. Then we will use this one option. I just click here, sorry, I just click the member and I just click here, and if you want to see the which of the members are failing, so you can click on the NG. You can see these are the members are fail. And if you say OK, only the pass member you can see. I just click here, I just say graphic. Now in the graphically you can see all the values. I just say member force, design parameter, checking the results for the slenderness ratio, axial strength, bending strength, combined strength, shear strength, entire thing. One more thing is I just click here, and if I say detail, now in the detail it will show about the formulas, according to the which formula the values are calculated, and it is showing about the specification from the D1 L by R equal to 58.2 and is less than the 300, so it is okay. So axial tension member, or this one axial strength, flexural strength, major axis, minor axis, the entire thing will be checked, and it will show the formula basis on the your specification provision D1.1b table D1.1. so these are the options are available. Then some of the members are fail. Now you can see I just say NG, so these are the members are fail. Okay, I just click here member first, NG, these are the members are fail. I wanted to see which members are failing, so what I will do is, now we can see in the screen, just click on the connect model view and I just say select all. Now which are the elements I am selecting, you can see here only these are the members are fail, the rest of the members are pass. If you want to change this one, you can update the properties, or else you can just say section for design, and you can select this one, modified it, and program will automatically take care. But this is not the final analysis, because here the program will design the member according to your previous movements and the forces, and if you want according to the new movement and the forces, so you need to generate the new one. Okay, so these options are available. Now second, if I do not want this to use this option, and I wanted to see the past member, means I just click here and I wanted to use the section property, means we are having one option to change the property. The program will automatically tell you which are the members are passing. So I just click here, I just say change. Now in the change, it will ask AISC. This is the type of the your grade, this code. This is the shape of the member. You can restrict the your height, means in the particular range or particular height you wanted to check the member, you can check. Even for the width, even for the flange, even for the web, even you can limit your combined ratios also. I just say 0.95, and if I say search satisfied section, now here below you can see the program will automatically search for the satisfied section. Now here these are, if you use this type of the member, the program will pass your section. So I just use say W 8 by 86, say 1865, instead of that I will use this one, say change and close. Now here you can see check member. So now this is the member is pass. For the same way here, change and search for sections. Now this, if you use this one, then it will pass. It required this one. I just click here, say change and close. Now plus. So now these are the options are available, but now using this option, what happen is program is check the values, but these values, it is not according to your modify stiffness, it is according to the previous forces. Okay, another option is available is still design, just say still optimal design. Now in the optimal design, what happen, I just click here, the program will automatically first design the member, or else we can say check the member, and based on the checking the program will tell you whether it is passing or not. I just click here. Now here you can see all the members, so I just click here, I want to change this member. D1, it is the dimension that you can get it from our manual, help manual. This is only the dimension of the D1, D2, these are the dimension of the sections actually. So this option is available. You have to always click this 000, because the program will automatically calculate. If you put some values, so based on that value the program will check the values. Then analysis option, how many times the iteration you want, you can change the iterations, say 3, or I just say 5 times. Plate thickness if you want, column design if you want, according to the internal construction, external costing, axial forces or something. Then entire things, these options are available. And then if I say design and analysis, the program will automatically design, and it is the design according to the 5 times, and then it is giving the final optimized value. No need to check it, program will automatically optimize it and give the final value. So these are the options are available to design the steel structure. And the lastly and the most important, what are the section you are seeing here, you can just say file, export, and just say AutoCAD DXF file. I just click here, and if I say all element, center line and plus shape, frame thickness and the plate thickness, so entire section it will automatically transfer into the AutoCAD drawing. Now over there you can directly get the exact section, even with actual your sections, and then you can move for the drawing, for the drawings also. At least you can get the shop drawings, not the connection detail. For the connection detail you need to use the design plus, but these are the options are available to design the steel structure. So if you have any doubt you can ask us, or else you can mail us on the techsupport@midasIT.com. We will try to solve your problems, and the various options are available. I just show about only the introduction part, and the same various options are available for the designing the member, to draw the members and the other things. So if you have any doubt, you can just ask me.